Good morning, dear students. Today is our the fifth practical lesson. Previous lesson was about definite integrals, so we were calculating definite integrals, and today topic for today is application of definite integrals. So we will calculate definite integrals to find areas. Volumes, lengths of the curve, static moments, and so on. Let me share my screen. So how to find the area of the region? So in this, in the first exercise, so 1a, we have to subtract. So first of all, we draw the graph of the functions of these curves, and we see which region is bounded. So we subtract upper bound from lower bound, and then integrate this expression. So as we see from the graph, so the first so the upper bound is 2 minus a square minus x square, and the lower bound y equals x. Okay, let's calculate this integral. So let's calculate the area. Yeah, and how to define the points. So how to define the bounds of integration? We need to find the intersection points of these graphs. So here is point -2, -2, and here 1, 1. So x from -2 to 1. So 2 minus x square, so the upper bound, and the lower bound x dx. So now let's integrate using Newton-Leibniz formula. So 2x minus 1 over 3x cubed minus 1 over 2x square. And now let's do the substitutions. So 4 minus 8 over 3 minus stop. Yeah, a little bit confused. So 1 minus 1 over 3 minus 1 over 2. Yeah, because we we substitute 1 first of all, and I confused it with 2. And here minus 4 plus 4 plus 8 over 3 and minus 2. Vitaly, yeah, you have a question?
Why is there in the first half a 1 if it shouldn't it be a 2, since 2 by 1 is 2, yes.
Yeah, thank you for your attention. Or maybe just misclick on the keyboard. So that's the reason. So what can be cancelled here? Or nothing. So okay, 2 plus 4 plus 2. Okay, 8. And here minus 1 over 3 minus 8 over 3. So minus 3 and minus 1 over 2. So it will be 5 minus 1 over 2, and it will be equal 9 over 2. Yeah, so the same. Okay, any questions about this exercise? Okay, no questions. So let's uh, see other uh, exercises and just to understand. So if we will now solve all tasks or not all of them. Okay, so now let's move to the exercise 2. So other parts, so part B is analogical, but for B we just integrate. Yeah, so we do. Mhm. Uh, Here is a mistake. We integrate by y, so it must be dy here and dy here. So we just so in this exercise in B, it will be the top bound and oh no, oh no. So here is this is the top bound and this is the bottom bound. Okay. Let's move next to exercise 2. Again, we will calculate. Hmm, so we have just one section here. So we have to calculate the area bounded by the x-axis and the first arc of cycloid. Let me just show you how the cycloid looks like. So uh, 3 by 2 over 2 by t minus sine t, and 3 by 1 minus cosine of t. Oh no. Okay, what's going on? Okay, I just forgot syntax a little bit. Yeah, so around brackets, not figure. Yeah, and the first arc of cycloid corresponds value of parameter from 0 to 2p. If I change to 4p, it will be two arcs of cycloid. But 2p will be enough for us. So if we find the area of the first arc, so this one, we will find, so we can find any such area. So okay, let's move next. So now we need to calculate the integral. So which integral must be? So for parametric function, it's so this is the following integral. So x oh stop. So y prime by from t and x prime. Oh no, y from t multiplied by x from t dt. Actually, dx equals x prime from t dt. So y such form. So let's find dx in our case. 2 multiplied by 1 minus cosine over t dt. So from 0 to 2p, and let's multiply. So first of all, 3 over 1 minus cosine of t, and multiplied by 2 over, or 2 multiplied by 1 minus cosine of t dt. Then now let's write it in a more compact way. So we'll have just square, and now let's expand the brackets. So 1 minus 2 cosine of t plus cosine square of t. And now let's let's reduce the power here. So plus 1 over 2 plus 1 over 2 cosine over 2t. And let me use other brackets just for more more beautiful form. Okay, now let's let's also add 1 and 1 over 2. So it will be 3 over 2. And now let's integrate. So 6 multiplied by, and with substitutions. So 6 multiplied by 3 over 2t minus 2 sine over t plus 1 over 4 sine of 2t. And from with the substitutions from 0 to 2p. Okay, sine of t and sine of 2t will be eliminated because of substitution 0 and 2p. And which addend is interesting for us, 3 over 2t. So it will be, so 6 multiplied by 3 over 2 and multiplied by 2 p. And the result is 18p. Any questions about this exercise? Okay, let's move next. This third exercise, and we will calculate the area bounded by such curve, Bernoulli-Lemniscate. So this is the function given in polar coordinates. I guess you already know what do polar coordinates mean. So rho is the radius vector, so the distance from beginning of coordinates, and phi is the angle between x-axis and uh, so so for example, let me just remind you about polar coordinates. So annotations don't work. So, so this angle is phi. So between this axis and ray. Okay. Now let's put the graph just to understand how does it look like. So rho square. Oh no. Equals a cosine of cosine a square cosine over 2 phi. Here theta is used. Too many variables, understood. So we need to, yeah, let's add slider for a. Yeah, okay, it must be linear. So let's write like this. So r equals a and square root of this figure. And if minus, oh, actually the same. Okay, so for volume of Bernoulli-Lemniscate, it will be, so we will have to integrate from 0 to 2p this, so rho square. Okay, so we use the following formula. Okay, so for polar coordinates, so it is found by the following formula. So in this case, a rho square. And in our case, so here is already given a rho square, so it's convenient for us. So let's calculate from 0 to 2p. So from 0 to 2p, a square cosine over 2 phi d phi. So let's integrate it. Stop. It seems that here is a mistake here. Scale of Bernoulli, yeah. So let me remember this formula. Cosine of 2 phi. Yeah, and it seems that something that this integral will be similar, so will be equal to 0 if so. Just a moment, just a moment. So we need to Yeah, so here is a mistake. So let me see what is wrong. Yeah, maybe I need to choose other bounds of integration. I guess that it must be so another uh, so other bounds. Yeah, so actually how to calculate it. So for example, if from minus p over 4, yeah, so we need to choose the correctly bounds of integration by p over 4. So if we choose such bounds of integration, we will find this part. And it will be our figure. So so we will find this part and just multiply it by 2. So this is the idea. And we even can integrate from 0 to p minus 4. Why not? Yeah, and by the way, I forgot to multiply it by 1 over 2 here for polar coordinates. So let's write like this. 1 over 2 from 0 to uh, p over 4. So now it will be normally calculated. So 2a square, even 1 because we will divide it. And sine over 2 phi with substitutions from 0 to p over 4. So it will be a square. And that's the area of the Lemnis gate. Any questions about this exercise? Okay, if no questions, let's move next. So now we need to find the length of the curve using the integral. So how to calculate the length of the curve? We have to calculate the following integral. So from a to b, uh, uh, so y, so f from x dl. So we'll just oh oh we just need to calculate this. So dl differential of the curve length. So how to calculate this differential? So for explicit function y equals 1 over, so y equals f from x, it is the following. Y prime in power of 2 plus 1 dx. So in our case, y, so the function is given in implicit form, so let's write it in the explicit form. For x from 0 to 1, it will look like so square root from x cube. Yeah, and by the way, let's plot this graph. So y square equals x cube. So such a figure. And so for x, so for positive x, so y equals x, yes, a square root of x cube. So we have such a part. Yeah, but what is interesting for us, so x from 0 to 1, so we will calculate for this, half of this curve, and then we will, so we will just multiply it by 2, because what is interesting for us, so which part do we have to find, annotations. So we need to find this part. So both these parts. Okay, let's start calculating. So first of all, let's differentiate y. So y prime equals, so uh, so 2 over 3, and so x, so my and square root of x. Oh, stop. 3 over 2. Sorry. 3 over 2 and square root of x. Then y prime, y prime square equals 1. So 9 over 4. 9 over 4 x. So dl equals, in our case, it will be equal 1 plus 9 over 4 x dx. And in our case, which integral we will have? So from 0, so 2 integrals. So 2 from 0 to 1, and this expression. And now let's integrate. So let's use differential entry technique. So 2 multiplied by 4 over 9. And here will be the differential of this expression. So 8 over 9 multiplied by 2 over 3, and this expression with substitutions from 0 to 1. Yeah, let me delete the annotations. So with substitutions from 0 to 1, so we have the following. So 16 over 8 over 27. So 1 plus 9 over 4. And square root from this expression. And minus 1. Okay, so let's calculate. So So 16 over 27 multiplied by 13 over 4. So 13 over 4 and square root of 13 over 4. So let's move to here. So this, so such irrational answer. So this is the final answer. Any questions about this exercise? Yeah, by the way, so this result is positive. Of course, we can expand brackets, but does it really make sense? I don't think so. Okay, if no questions, let's move next. Then, so we need to find the length of the circle. Let me not draw the circle. Let's find the just length of the quarter of the circle. Yeah, and by the way, here is explicit. So explicit form of the semicircle, so that is on the top. So now y equals square root of r square minus x square. So this semicircle. So the explicit form will be the following. So y equals r square minus x square. Then y prime equals minus x over this expression. So here it was 2 in the numerator and in the denominator, and I just canceled it. So y prime square equals x square by r square minus x square. Then dl will be equal, so will be the following. So 1 plus this expression dx so it will be equal to r by this divided by this expression dx. Okay, so now let's integrate it. It will be enough to integrate from 0 to p over 2, and then we will just multiply by 4. Okay, so what do we actually have? So I move. So I move this. So r is moved here, dx here, and we have the So we will have a table integral. So it will be arcsine of x over r, and with substitutions from 0 to p over 2. Let me check if here is correct in my recordings. Yeah, so x over r. Yeah, so it's yeah, my bad. Yeah, and here will be 2, so we calculate for half of the uh, circle, because so not from 0 to p over 2. Yeah, so it's not a parametric graph but explicit. So so x will be equal from 0 to r. So yeah, it will be okay. So leaving 4 here, so from 0 to r. So that's okay. Yeah, so actually for parametric equation of the circle, it would be easier to calculate the length, so because it's just a more convenient form. Okay, so 4r multiplied by, so arcsine of 1 is equal uh, to p over 2. Arcsine of 0 is equal to 0. So surprisingly, the length of the curve is equal to 2p r. So the formula that you know from the school. Any questions about this exercise? Okay, if no questions, let's solve a couple of tasks about length of the curve, and then we'll have a break. So exercise number 6, we have the following function. So how to calculate how to find the differential of length of the curve for polar coordinates? It looks like this. So rho square plus rho prime square d phi. So rho square. Oh no. Okay, let's calculate rho square and rho prime. So what's going on? So rho square equals a square by 1 plus cosine of phi. Rho prime equals minus a sine sine of phi. Then rho prime square equals a square sine square of phi. Let's add these values. So a square will be out of brackets, And what do we have? 1 plus 2 cosine of phi. 2 cosine of phi plus cosine of phi square. Square of cosine of phi plus square of sine of phi. Then so let's collapse it a little bit. So let's reduce. So 2 plus 2 cosine over phi. And if I go, so the differential of the length of the curve will be the following. So A over 2 plus 2 cosine of phi dp. But it's not convenient to calculate square root of trigonometric expression. But here we see the formula of mm, so reduction of the so power reduction. So a square and multiplied by, so let me just remind it. So 1 plus cosine over phi is equal to 2 cosine square over phi over 2. So yeah, so here we have 4 cosine square of phi over 2 d phi. And now let's also remove the square root. So we will have 2a of such cosine with now in power of 1 and d phi. So found the differential of the length of the curve. Yeah, and by the way, how the cardioid does look like. So cardioid is the following. So it is symmetric from so symmetric to axis of x. So we can calculate integral from 0 to p. So let's do it. So L will be equal, so the following integral, so from 0 to p, and this expression. So what do we have? So 2a, so it will be equal a over sine over, so a multiplied by sine of phi over 2 with substitutions from 0 to p. So sine over p over 2 is 1, so the result is a. Any questions about this exercise? Yeah, by the way, sorry, 2 here and 2 here, because we need to, so we just calculated the half of this cardioid in this integral, but we need to multiply it by 2. So any questions about this exercise? Okay, if no questions, let's solve one more exercise with the cardioid with the length of the curve, and then we will have a break. Let's first of all plot the asteroid, just to understand how does it look like. Or maybe I need to do like this. Yeah. From t from 0 to 2p. So how it does look, how does it look like? So like a star, so why asteroid, and why it is symmetric, so p over 2, so it will be enough to calculate only in this quarter and multiplied by 4. Okay, how to calculate the differential of the curve length for parametric curve? So it is the following. So x prime from t plus, yeah, by the way, in power of 2 plus y prime in power of 2 from t dt. So let's calculate this derivatives. So x prime from t equals 6 sine, so minus 6 cosine square of t by sine of t. Y prime from t equals 6 sine square of t and by cosine of t. Okay, so let's now calculate this expression. So 36, so cosine in power of 4 and sine in power of 4 plus 36 from multiplied by this expression also in, so sine in power of 4 and cosine in power of 2. Now let's move 36 sine square from t cosine square from t out of brackets, and what we will receive, so cosine square from t plus sine square from t, and it will be actually equal to 1. So such expression. So dl will be equal to this expression and dt, and so it is equal to 6 sine of t cosine of t dt. And by the way, let's also collapse it with the using formula of so it will be 3 sine over 2t dt. So we just simplify it a little bit. So now let's calculate the integral. So L is equal, so 4 integrals from 0 to p P over 2 of 3 sine of 2t dt. So, what do we basically have here? So, minus cosine over 2t from 0 to p over 2. And so 6 basically, because we divide by 2. So it equals, so minus 6 by, so cosine of p equals minus 1, and cosine of 0 equals 1. So it equals 12. Any questions about this exercise? Okay, if no questions, let's have a break for 5 minutes, and then we will calculate volume and static moments, moments of inertia, and so on. let's continue. Okay, so now we have to find the volume of the body found uh, so formed by rotation of the plane figure, uh, so bounded with the following lines: x y equals 4, x equals 1, x equals 4, y equals 0 around x-axis. So how to do it? So first of all, let's plot these curves that bound the figure. So x, y equals 4, x equals 1, uh, x equals 4, and y equals 0. So actually, this segment, so we have the following region. By the way, where is toolbar? Oh, I don't share my
Sorry,
screen.
could you share your screen? Yeah.
Yeah, so that's why I don't have this toolbar. So we have such bounds of the figure. So how it looks like on the graph. So this something. So it is lag a little bit. So this figure is rotated around x-axis, and we have to find the volume of this figure. So how to do it? So we need to write this this function in explicit form, and bounds of integration are defined as yeah, by the way, so how to calculate the volume? So it is calculated by the following formula: P. So if the axis of rotation is x, so from A to B, f uh, f square from x dx. So this is the volume of body of rotation. If rotation is around y-axis, we just change it to y. So now we need to use this curve. So explicit form of x over xy equals 4 is the same is as 4 over so the same that y equals 4 over x. So and the bounds of integration are 1 and 4. So from 1 to 4, 16 over x square dx. So what do we have? Minus p minus 16 p multiplied yeah yeah, and let's also write so this substitution, so Newton-Leibniz formula. So substitutions from 1 to 4. So minus 16p and so 1 over 4 minus 1, and it will be so 16 16 p multiplied by, what's wrong with hotkeys? Or I just press too fast. Okay, multiplied by 3 over 4, so it equals 12p. So found the rotation, body of rotation. Any questions about this exercise? Okay, if no questions, let's move next. So now we need to find the volume of the part of a paraboloid formed by rotating of the arc of a parabola. Y equals x square from x for x from 0 to 2 around y-axis. So y equals x square, and so yeah, so x from 0 to 2. So this part of parabola, and we actually have the following body. So we rotate this figure, and we receive part of paraboloid, and we have to find it. So let's do it. So in this case, we have to explicitly, oh, yeah, sure. So we need to give explicitly function from uh, function x from y, because we rotate around y-axis. So y equals x square. Then, so for our case, x equals square root from y. So what do yeah, and by the way, we need to specify values not of x but values of y in such case. So from 0 to 4. So from 0 to 4, y dy, and we integrate this function. So the following integral, so p over 2 y square with substitutions from 0 to 4. So it will be 8p. Any questions about this exercise? Okay, if no questions, let's move next. To the next exercise. So we need to, okay. So rotation of cardioid, so around the polar axis, and we need to find the volume of revolution. So let me remind you the formula of cardioid. And if we'll specify from 0 to p. So polar axis is the following, so x-axis, and formula of the volume is the following in this case. So volume equals of 4 4 over 3 p and from so from alpha to beta, rho cube d phi. So the following formula is used for finding areas, and yeah, it's not such convenient form, but let's calculate. So rho cube, it will be equal, so a cube and 1 plus cosine over phi in power 3. So let's expand the brackets. 1 plus, so sum of squares. So 1 plus 6 cosine over phi. Oh, no, not 6, 3 cosine of phi. Plus 3 cosine square of phi. And plus cosine cube of phi. And it must be all that we need. Yeah, and by the way, let we also, okay, now let's write it as sum of integrals, and then a lot of things will be simplified. So we integrate from 0 to p. Yeah, this multiply, don't forget it. Yeah, and I also will move a cube out of brackets. And I have this expression and multiply it by d phi. Then, yeah, let's write it as a sum of integrals. Okay, I will simplify it now. So here is just d phi. Here 3 cosines of phi. And here 3 cosine square from phi. And here cosine cube of phi. So we will integrate them one by one. Some of integrals will be successfully eliminated. That will simplify our work. So this integral will be actually, so it will be p with the substitutions from 0 to p. Okay, let me also write it in details. And this integral is so plus 3 sine of phi. That will be actually eliminated. Then let's reduce power here. So 3 over 2 and 1 plus cosine over 2 phi d phi. And here we will have to use the differential entry technique. So 1 minus sine square over phi and multiplied by a differential of sine of phi. And now let's rewrite what we receive. So here we have just P. It is 0. So sine of P minus sine of 0. Then here, what do we have? Phi plus 1 over 2 sine of 2 phi. That also will be eliminated successfully. And here, so sine of phi minus 1 over 3 sine cube of phi. Yeah, and forgot substitutions everywhere. So from 0 to p, and here as well from 0 to p. So what do we have? So 3 over 4 over 3a cube p multiplied by so p plus 3 over 2 p, and it will be 0 here and 0 here. So now let's finally simplify this expression. So 3 over 2 plus 1, it will be 5 over 2p. So 5 by 5 over 2, and how can it be simplified? So 2 over 5. Okay, so what do we have? So 2 by 5, so 10 over 3 a cube p square. And that's all. Any questions about this exercise? Okay, if no questions, let's move next. So yeah, a lot of calculations, but it's done. Okay, so now, yeah, it's almost done. So we have, so task 11, let's find the volume of the solid, of revolution obtained by rotating arc of cycloid around its base. So the base of means x, so x-axis. So what do we have to do? So the formula is a little bit similar to explicit function, but so yeah, of course, also we multiply by p, and here we have y square from t multiplied by x prime from t dt. So actually x, so dx equals x prime from t dt. So what does it mean basically? So why do we write in such way? So I explain you for better understanding. So just so you don't have to just only learn it by heart, but understand why x prime from t. So what is interesting for us? Yeah, of course, let's calculate this expression. So first of all, x prime from t, it will be equal a 1 minus cosine over t. Minus cosine of t. Then y square from t. And by x prime from t, it will be equal a cube. Again, so cube of difference. Okay, but we will succeed to calculate it. So cosine of t in power of 3. So let's write everything in brackets. So a cube, 1 minus 3 cosine of t plus 3 cosine square of square, not cube, square of t, and plus cosine cube from t. So now we have to calculate the following integral from 0 to p. Yeah, and let's move a cube here. And by the way, let we calculate all integrals separately. So, yeah, let's first of all rewrite it like a sum. Oh no, let we first of all write this expression. Simplify with the reduction of this power. So a cube and here plus 3 over 2 cosine of 2 plus 3 over 2 cosine over 2t. So here we will have 5 over 2. And now let's calculate all integrals separately. But I will, before it, I will make another recording, so the integral will be written in this form. So I1 equals 5 over 2 from 0 to p dt. So it will be just equal 5p. Then so E2 is equal minus 3 integral from 0 to p cosine of t dt. So it will be equal my cosine of t. It will be equal minus 3 sine of t from 0 to 2p. Yeah, I need to move out of integral sign. So from 0 to 2p, and it is actually equal to 0. Then I 3 equals yeah, so actually the similar integral, but 3 over 2 cosine of 2t, and it is equal to minus 3 over 2 sine of 2t. From 0 to 2p, that is also equal to 0. Then okay, let me not calculate this integral so in details. We will just write that cosine square of t, so this integral will be equal to 0, because we already know it from the previous exercise. So the final answer will be a cube p multiplied by 5p. So the final answer is 5a cube, not alpha, 5a cube p square. And that's it. Any questions about this exercise? Okay, if no questions, let's just look at the last exercise. So exercise 12. Here we have arc of the circle, so positive arc. That is located in the first coordinate quadrant, and we need to find the mass, static moments, and moments of inertia with respect to x and y axis, and the coordinates of the center of mass. So mass, how to find? We need to find, and yeah, and linear density is constant. How to find actually the linear density? How to find mass? We need to integrate linear density by values of x. So we integrate, so we find it by this formula, and it equals 3 mu 0. Then how to calculate static moments? They're found by these formulas. So we need to use okay, let me remind you a little bit. I don't remember it, but clearly. Okay, let me remember it a little bit. How to use? So which formulas must be used? Yeah, for static moments, the following. So m x, so moment from relative to x-axis is calculated by this formula. For y, so it is calculated, so vice versa. So that's why it looks like so. So we for x we substitute this expression instead of y. So 9 minus x squared. And here we just substitute x. Then moment of inertia. So how it is calculated? Moment of inertia is so the following form. So for moment of inertia relative to axis of x is the following from A to B. Yeah, and 1/3 integrals from A to B y cube dx. And for y-axis, we can use the following formula. So from A to B, x y dx. X cubed y. So, and these formulas are used here as well. So you can see it in your own. Yeah, and how to find coordinates of center of mass. No, we just need to so just a moment. Yeah, so we need to divide so x so xc equals 1/L. So 1 divided by length of the curve, and the integral from A to B x dl. So actually, analogically to static moments, but another multipliers. So no. So for static moments, vice versa, but for coordinates of center, so variables match. Any questions about this exercise, about the whole lesson, previous lessons? Okay, if no questions, so let's finish. We already are behind, so have a nice day. Stay safe. Thank you for your attention. Goodbye.
Thank you. Goodbye. Have a nice day.
Thank
Thank
you
you a
for the
lot.
lesson.
Take